graph the hyperbola. So we have x squared divided by 4 minus y squared divided by 16 equals 1. Remember what the standard equation looks like in this form. It's x squared over a squared minus y squared over b squared equals 1, right? So here's the trick. This is the memory trick you use to help yourself remember how to graph this. You start out like it's an ellipse. Start out like it's an ellipse. So find the center. Well, the center in this class is going to be 0, 0. And you're going to go left and right how far? So you're going to go if this were an ellipse, if this were a plus right here, you would go left and right from the center, the square root of this number, to get to the edge of the ellipse if it were an ellipse, right? Okay, so let's go left and right 2. So let's go left and right 2. So I'll say it this way. A squared in this case is 4, which means a equals 2. I'm ignoring the plus or minus because I consider a length. So you go left and right, plus and minus 2 from the center. Okay, then you're going to go up and down how far? The square root of the number underneath y squared. So b squared is 16, which means you go up and down the square root of that number, which is 4. So up and down, 1, 2, 3, 4. 1, 2, 3, 4. Now, if this were a plus right here, you'd just draw the best oval you can and you'd be done, right? But it's not. So what I'm going to do is I'm going to draw a box. And the diagonals of this box are going to correspond exactly to those asymptotes. So if you draw the box with that has these 4 points as midpoints. So draw the box that has these 4 points as midpoints. And then draw the extended diagonals of the box. Now I am going to cheat a little bit here. I'm going to use my drawing tool for a line to draw the extended diagonals of the box. So the diagonals go from corner to corner, right? Opposite corner to opposite corner. So there's one extended diagonal. And that's going to be one asymptote. And then the other one like so. Everybody see what I did there? Now, if it were perfect, the center where these asymptotes cross would be 0, 0. Of course, it's drawn a little bit freehand there, so it's not perfect. Now, why are those the asymptotes? Well, think about it. The equation of something like, if you just take the one that's positive, the equation of y equals a over b times x, that's a linear equation. It's a line, in other words. It has to be a line, and it goes through 0, 0. Well, you know, I should, to make it match what we're doing, I should make it the first one. So y equals b over a times x. So same thing, though. It's a linear equation, and it goes through 0, 0. So where does the box come from? Well, think about it. What did I do to create the box? I went up a distance of 16, root 16, I should say, which is b, right? So I went up a distance of b, which is turned out to be 4 in this case. And to get to this corner, I went over a distance of a, which was 2. So think about it. What's the slope of that line? It's b, the b is the rise, over a, which is the run. Well, that's exactly what we derived right here. The slope is b over a. So that's why it works. Now, you don't have to, all you have to remember, let me put it this way, is how to draw the box. And so if you can remember how you draw the ellipse you would have if that were a plus in between the x squared term and the y squared term. If you can remember that, then you can remember how to draw the box. Okay, so then none of what I've drawn is the hyperbola so far, except for 2 points. These 2 points, here and here. Those are called the vertices, plural of vertex, of the 2 branches of the hyperbola. Now, because the x squared term comes first, we know it opens left and right. We know that there's a branch that opens left. We know that there's a branch that opens right. And we know that it's going to follow these asymptotes. So all you have to do, long story short, is draw a hyperbola, one branch that opens to the left that goes through this left-hand point, this left-hand vertex. And it should look like it gets closer to the asymptote, so try not to fade away like I did a little bit there. Should look like it gets closer to the asymptote as it goes to the left. And then the other branch should look like a mirror image of it. It should look like it gets closer to the asymptote as it goes to the right. And so we don't really plot any points except for the 2 vertices in the middle of the box, the middle of the 2 opposite sides of the box, the vertical sides in this case. Okay, so the graph in blue, that graph, those 2 branches make up the one hyperbola.